Dear students, in this video we will discuss about polar and non-polar molecules and how we can differentiate the polar molecules from the non-polar molecules. Okay, now look at the object. As you can see here that there are the equal number of the positive and negative charges. So overall, the net impact of these charges is zero. That is, we call such object neutral because positive and negative charges cancel each other. So the overall net charge is zero. So this is neutral object. Now look at this object. This object has net positive charge. So such object is called as positive ion. Okay, now look at this object. It has net negative charge. So this object is called as negative ion. As here you can see that there are the positive charges and negative charges. That is, one side is positive and the other side is negative. That is, there are the separation of the charges. One side is partially positive and other side is partially negative. Such an object, when here the charges are polarized, so such object will be called as the polar or polarized because there is the separation of the positive and negative charges. Okay, now we have an hydrogen. In hydrogen atom, there is one electron revolving around the nucleus, positively charged nucleus. So it needs the one more electron to complete its orbit. Now we have another atom like fluorine. In fluorine, there are the 7 electrons in its valence shell. So the fluorine needs the one more electron to complete its orbit. So hydrogen come close to the fluorine, so now both are sharing their electrons, but here the thing is that this sharing is not equal. This sharing is not equal because the hydrogen has the electronegativity of 2.1 while the electronegativity of fluorine is 4. So the electronegativity difference is more than 1.5 electron volt. So such objects, these are called as polar. This molecule is the hydrogen fluoride is the polar molecule because electronegativity of fluorine is more than hydrogen atom. So it means that the fluorine is partially negative while the hydrogen atom is partially positive. As the fluorine is partially negative because it having the more number of electron as compared to the hydrogen atom, and its electronegativity value is more than hydrogen atom, so the electron cloud attracted more towards the fluorine. That is, electron density is more towards the fluorine as compared to the hydrogen atom. So this makes the in hydrogen fluoride molecule, it makes the fluorine end as partially negative and hydrogen end as partially positive. So hydrogen fluoride molecules, we can say that it's like polar molecule, having the one side partially positive and the other side is negative. So it is called as polarized. It's a polar molecule. Hydrogen fluoride is polar molecule because there is the separation of the charges, positive and negative charges. Electron density moving towards the fluorine, more towards the fluorine, so electrons are on the fluorine sides as compared to the hydrogen. So fluorine side is the negative and hydrogen side is the partially positive. So these objects become polarized, or this molecule, hydrogen fluoride molecule, is polarized. Now, first of all, we will discuss the polar molecules. As we have already discussed about hydrogen fluoride, let's again take an example of hydrogen fluoride. As in the hydrogen, we have the one electron revolving around its nucleus, around the positively charged nucleus. And the fluorine. Fluorine has the 7 electron in its orbit and share its electron with the hydrogen atom. So, as we know that there is the unequal sharing of electron because of the electronegativity value of fluorine the 4 while hydrogen is 2.1. So electronegativity value of fluorine is more than hydrogen atom. Electronegativity difference is more than 1.5. So it's a polar molecule, and electron density, electron cloud is more toward the fluorine as compared to the hydrogen. So we can say that there is uneven sharing of electron. It's not equal sharing. That is, electron cloud is more toward the fluorine. It's unequal sharing of electron. So whenever there is unequal sharing of electron, that is, bond is between the highly electronegative element and with the element of low electronegativity. So when there is the bonding and electronegativity difference is more than 1.5, then it is a kind of polar molecule and there will be the unequal sharing of electron. So there is the unequal sharing of electron between two atoms. So such a molecule are called as polar molecules. As the hydrogen is partially positive because its electron cloud is towards the fluorine as compared to the hydrogen atom, and while the fluorine side is partially negative. Now let's talk about the non-polar molecules. Non-polar molecules, again, we take an example of hydrogen atom. As the hydrogen atom has one electron revolving around the positively charged nucleus, so it needs the one electron to complete its orbit. So when this hydrogen atom shares this electron with another hydrogen atom, so both are the hydrogen atom, so having the electronegativity value of 2.1, so there is equal sharing of electron. So both this electron cloud is shared equally among both hydrogen atoms. So there is the equal sharing of electron. We say that there is the equal sharing of electron between the hydrogen molecule. So there is no separation of the charges. There is no separation of the positive and negative charges, both atoms having the same value of electronegativity. Such a molecule are called as non-polar molecules. So let's take the other examples of non-polar molecules. Like we have example of iodine molecules and the bromines. So all those molecules which consist of the same element like bromine, iodine, oxygen, nitrogen. So all such a molecule will be the non-polar molecules because there will be the equal sharing of electrons. Now look at the example of hydrocarbons. So when there are the hydrocarbons, that is when the carbon and hydrogens are involved. So this one is the carbon and this one is the hydrogen. As we know that the carbon has the 4 valence electron, and so it can share these 4 valence electron with the 4 hydrogen atoms, making the 4 covalent bond. Yes, in these bonds, again, there is the equal sharing of electron between the carbon and hydrogen, because if we look at the carbon-hydrogen bond, so electronegativity value of carbon is 2.5 while electronegativity value of hydrogen atom is 2.1. So the difference in electronegativity is 0.5. So since this difference is less than 0.5, so it means that this one is the non-polar molecule. So all hydrocarbons are non-polar. All hydrocarbons, it means that the molecule which containing the carbon and hydrogen, that is the carbon-hydrogen bond, is non-polar bond having the electronegativity value less than 0.5. So all hydrocarbons will be non-polar molecules. So these are the non-polars. Now we look at another example like carbon tetrafluoride. We discuss geometry of the carbon tetrafluoride, but before going to geometry, we need to discuss its bonding. As in the carbon tetrafluorides, there is the carbon and fluorine bond. So the electronegativity value of the carbon is 2.5 while the fluorine is 4. So electronegativity value of fluorine is more than 2.5. As we have seen that in the case of hydrocarbon, the electronegativity difference is less than 0.5. So that bond was the non-polar bond. But here in the case of carbon tetrafluoride, the electronegativity difference is more than 0.5. So this we can say that the carbon side is partially positive and while the fluorine side is partially negative. So here the sharing of electron between the carbon and fluorine will not be the equal sharing of electrons. So the electron cloud will be more towards the fluorine side because it's having the higher value of electronegativity as compared to the carbon atom. So electronegativity difference here is 1.5, that is more than 0.5. Whenever the electronegativity difference is more than 0.5 or 1, then that bonding will be the polar type of the bonding. So the bond between carbon and fluorine is the polar bond. Now we look at the geometry of the carbon tetrafluoride like this one. Now here you can see that the carbon atom sharing its 4 valence electron with the 4 fluorines. So the bond angle between them is 109.5 and so the geometry will be the tetrahedral geometry. So now look at the carbon fluorines, as the carbon side is the partially positive side while the fluorine side is partially negative side. So if we look at the dipole moment, the dipole moment always point from positive side towards the negative side. So it's always from carbon to fluorine. Now look at the geometry and here we draw the dipole moment. So it is from carbon to fluorine like this one and this one. Now look at the dipole moments. If you look at the dipole moment of this carbon and fluorine and this carbon and fluorine are going to cancel each other, and while these from dipole moment of this carbon and fluorine and among this bond also going to cancel each other. So we say that the net dipole moment is 0. So this bond is the non-polar bond. Although non-polar molecules, although the bonding is the polar because of the electronegativity difference, but if you look at the geometry of these molecules, the overall the carbon tetrafluoride is non-polar molecule because the dipole moments cancel each other. So net dipole moment is 0. So this molecule is the non-polar molecule. Okay, now we look at another example. Like we look at the example of hydrogen molecule. In hydrogen molecules, there is the hydrogen and oxygen. That is, there is the bond between hydrogen and oxygen. So the electronegativity of hydrogen is 2.1 while oxygen is 3.5. So we say that the electronegativity difference is equal to 1.4. So this bond will be the polar bond and this molecule will be the polar molecules. Now look at the geometry of water molecule. Here you can see that the geometry is bent type shape because the hydrogen molecule, oxygen molecules which have the 2 lone pair of electrons. So the oxygen is the partially negative. Oxygen side is the partially negative because its electronegativity value is 3.5, that is more than hydrogen. So the electron cloud will be more towards the oxygen side. So the oxygen side is partially negative while the hydrogen sides are partially positive. So here you can see that the dipole moment will point from hydrogen to oxygen because the hydrogen side is partially positive and oxygen side is partially negative. So the dipole moment will be from hydrogen to oxygen and hydrogen to oxygen. But in this case, the dipole moments are not going to cancel each other. If we look at dipole moment like this one, that is dipole moment from this hydrogen to oxygen, and this one is the dipole moment from this hydrogen to oxygen. If we draw the component x and y component of these dipole moment, this one is the x component, this one is the y component. So this is the x component of this one dipole moment and this one is y component. If you look at the x component, as the x component both points in the opposite direction, so the x component cancel each other while the y components are going to add up. They are not going to cancel each other. So there is the net dipole moment along the y-axis. So the net dipole moment is not zero in the case of water molecules. So we say that the water molecules net dipole moment is not equal to zero. So it is. Now look at the example of carbon dioxide and sulfur dioxide. We will differentiate which molecule is the polar molecule and which one is the non-polar molecules. First of all, we look at the geometry of carbon dioxides. Here the carbon atom sharing electrons with the two oxygen atoms. As here we know that the oxygen atom has two lone pair of electrons. So the oxygen side is partially negative while the carbon side is partially positive. Okay, now look at sulfur dioxide. Sulfur dioxides, we have the sulfur atom sharing electron with the oxygen. Sulfur atom has the one lone pair of electron while the oxygen has the two lone pair of electron. Again, sulfur side is partially positive while the oxygen side is partially negative sides. Okay, if we look at the electronegativity values. The electronegativity value of carbon atom is 2.5 while oxygen is 3.5 and the electronegativity of sulfur is 2.5. If we look at the electronegativity values, difference in the electronegativities is equal to 1. So it means that both bonding between these two molecules is the polar molecule. Both are the polar with respect to the electronegativity value, difference in the electronegativity. But if you look at the dipole moment, that as the carbon side is the partially positive and oxygen side is the partially negative side. So dipole moments points from carbon to oxygen. As here you can see that both dipole moments points in the opposite directions. So the net dipole moment is equal to 0. Here the net dipole moment is 0. So this molecule is the non-polar molecule. Although the electronegativity difference is 1, that is the bonding is the polar, but dipole moment is the 0. So it is overall this molecule carbon dioxide is the non-polar molecules. Now if we look at the sulfur dioxides. In the sulfur dioxide, the dipole moment points from sulfur to oxygen. But if you look at dipole moment, dipole moments are not going to cancel each other. Although the x component of both dipole moments which points in the opposite direction will cancel each other, but y component here you can see that are going to add up. So there is the net dipole moment. So the net dipole moment is not equal to 0 in the case of sulfur dioxide. So we can say that the sulfur dioxide is polar molecule. Carbon dioxide is the non-polar molecule while the sulfur dioxide is the polar molecule. So we can summarize our topic like this one. If the molecule consists of the same elements like oxygen molecules, nitrogen, chlorine, iodine, bromine. So there will be the equal sharing of electron among both the atoms. So such a case, the molecule will be the non-polar molecule. Secondly, if these are the hydrocarbon, that is there is the carbon and hydrogen bonding. If these are the hydrocarbon molecule is the consist of carbon and hydrogen bond. So here in this case the electronegativity value is less than 0.5, and again there is the almost equal sharing of electron. Then again all hydrocarbons are non-polar molecules. So if the molecules consist of different element, that like the hydrogen fluoride, that is one is more electronegative as compared to the hydrogen atoms, that is like the water molecule, carbon dioxide. Here you can see that there such a molecule will be the polar molecules, because the electron cloud is more towards the electronegative side as compared to the partially positive side. So that is the element which having the large value of electronegativity. The electron will be more towards that element as compared to other atoms. So there will be the unequal sharing of electrons. So we can say that the molecule which consists of different elements, that is the one is more electronegative as compared to the other, then in such a molecule will be the polar molecules. Thanks for watching.